When we're talking about cubic functions, there's three different forms that we can put our cubic functions in. There's three formats. Just like when we had quadratics, we had standard form, we had vertex form, and we had intercept form. We basically have the same thing with cubics, except since now our highest degree term is a cube, we have to have 4 terms in our standard form, and our exponent changes. So let's look at the first one, standard form. Now, if you look at standard form, it's very similar to standard form of a quadratic. But remember, since we have a cubic term, in a quadratic we had ax squared plus bx plus c. With cubics, you have the a term is now in front of a cubed term. So now we have 4 terms. We have ax cubed plus bx squared plus cx plus d. So that's standard form of a cubic. It's not much different than the quadratics that we've talked about, except for now we have an additional term. So your constant is no longer c, it's d. Now the critical information that's found in standard form, things that you can determine by looking at standard form right off the bat, is that d is your y-intercept. Remember in quadratics we did the same thing with c, because c was our constant. Here in cubics, d is our constant, so d is our y-intercept. So when an equation or a cubic is in standard form, right off the bat we can look at the d term, the constant term, the one that's not attached to a variable, does not have an x with it, and that is our y-intercept, where our cubic function is actually going to cross the y-axis. So that's standard form. The second form we have is called vertex form, or more commonly, transformation form. And we call it transformation form because the format actually gives you the transformation properties of the function. So this is transformation form here. Y equals a times the quantity x minus h cubed plus k. Now, if you remember, we also have a vertex or transformation form for quadratics. The only difference between the quadratic and the cubic, again, is the exponent. So whereas in standard form, I knew what the y-intercept was, when I have it in transformation form, I know a couple of things about my function. Okay? The first critical information that I have is my vertex. Remember, the vertex is the representation hk. So whatever the h value is, whatever it is that's being subtracted from the x in the parentheses, is the x coordinate of your vertex. And whatever's in place of the k on the outside is the y coordinate of your vertex. Now remember, because the value of h is subtracted inside the parentheses, when you write the coordinates of your vertex, the h value is going to be opposite of the sign that's in the parentheses. So for example, if I have x minus 5 squared plus 2, my h value is going to be the opposite of the sign inside. So it's not going to be negative 5. My h value would be positive 5. The k value, however, is going to take on the same sign that is in front of it outside, because the k value is added. Whatever is being added here is your k value. So if it says plus 2, your k value is plus 2. If this were to say minus 2, your y value and your k value would be minus 2. So that's your vertex. Now, the other thing that you can determine from transformation in vertex form is using your a value. Remember, your a value gives you a couple of different informational things about your graph. First of all, it can tell you if the graph is reflected. And we talked about this in quadratics. If the a value is negative, then the graph is going to reflect. If the a value is positive, then it will not reflect. The other piece of information that the a value gives you is whether or not we compress the graph or if the graph is being stretched. So those are the things that we can tell from vertex form. And this is called transformation form because the h and k, not only are they the coordinates of the vertex, but that tells you how we're moving the graph. So with h being 5, that means that I'm moving the graph from the original parent function 5 units to the right. And since k is 2, for example, in this one, 2 units up. So whatever h and k are, that tells you the left and right shift of the graph and the up and down shift. The A will tell you whether or not the graph is reflected, and it will tell you whether the graph is being compressed or stretched. So let's look at the last format we have for cubics, and that is intercept or factored form. And again, this is just like quadratics, except instead of having 2 factors, we now have 3 because we have a cubic function. Remember in quadratics we had P and Q. In cubics we have P, Q, and R. So in intercept form, the critical information that we find is the x-intercepts, which are also called the roots or the zeros or the solutions. And in this particular example, your x-intercepts would be P, Q, and R. So on the graph, this particular cubic will cross or intersect the x-axis at the value P, Q, and R. So let's say I gave you an example of intercept form. So we'll do y equals 2 times x minus 3, x plus 4, x minus 1. Let's say that's our cubic in intercept form. And I ask you, what are the roots or the x-intercepts of this cubic? Well, if you look at the intercept form, you're subtracting each root in each factor. So what is it I'm subtracting in this particular one? Well, the first one is 3, so my p-value is positive 3. And if you remember back to our previous lesson, we're basically looking for the values that make each one of these factors a 0. So 3 would be the one here because 3 minus 3 gives us 0, because that's what we want the y value to be when we cross the x-axis. Everything on the x-axis has a y value of 0. Every x-intercept has a y value of 0. So let's look at my q value. It's minus q. So just like up here where we take the opposite, you take the opposite here. I have x plus 4, so my q value is negative 4. That is the value that when I plug in gives me a 0 for my factor, so that when I do the product, I get 0 for my y value, which is where my x-intercepts are. So let's look at the last factor. My r value. My r value is positive 1. Again, x minus 1, so it's x minus r, it's 1. It's the opposite sign. So those are my 3 values. Now, before we finish, let's go back up and do an example of standard form because I didn't put one on there. So let's say y equals 3x cubed minus 2x squared plus 4x minus 7. When it's written in standard form, remember, the one thing we can determine is the y-intercept, and that is our d value. So if I saw this equation, this cubic, immediately I would know on the graph that the y-intercept of this cubic is negative 7, because this is going to hit the intersect the y-axis at negative 7. I know that because in standard form, that's the d value. And those are the 3 forms of cubic equations.